Hello, hi, my name is Aziz Busso. This is the month of October and I'm taking Mr. Okason's class. The topic that I have chosen today involves three things: speed, velocity, and acceleration. Speed, velocity, and acceleration is something as humans that we are absolutely obsessed with. The faster we travel in the real world, the more gravity works just to slow us down. For example, a question we always ask ourselves is, why can we not build a machine to travel at the speed of light? Stephen Hawking has calculated the possibilities of a machine accelerating at the speed of light, and the results that he got were very simple. We would have to have a machine that is infinitely huge with a engine that can infinitely accelerate for up to 6 years just to reach 99% the speed of light. And also keep in mind that it must carry a fuel source that will also last for full acceleration of 6 years to push the machine up to the speed of light. Here on Earth, we have the particle accelerator that can send particles up to 99% the speed of light. But another way for us to experience speed here on Earth is to experience it with cars, or planes, or any other vehicles that you have access to. For the sake of this experiment, I will focus solely on cars. There are many different type of cars in the world. Some are heavier, some are lighter, some are work trucks, some are meant for your everyday commute, and some are also semi trucks just to push all the goods around the country or imports and exports and things of that nature. For my main focus, once again, I will focus on a remote control car that can reach speeds of well over 100 miles an hour and the Bugatti Veyron as a comparison. The reason why I have decided to compare the Bugatti Veyron to a remote control car is because they are very similar. For example, if you compared in horsepower, the Traxxas X01 remote control supercar pushes 3.8 pounds of weight for every horsepower it has, as the Bugatti pushes 4.5 pounds of weight per horsepower that it contains. What this simply means is that the Traxxas remote control car can go from 0 to 60 miles an hour in 2.3 seconds and exceed 100 miles an hour in 4.92 seconds. Similarly, the Bugatti Veyron can go 0 to 60 in 2.3 seconds and 0 to 100 miles an hour in 5.5 seconds. Now you may ask, why does a game designer care about these statistics? The reason is simple. As a game designer, you have to be very flexible and know a little bit of everything. And this is simple physics of power to weight ratio. For example, in a shooting game, a character with a light machine gun should not be able to run as fast as a character with an auto rifle because the light machine gun is heavier. What this also has an effect on is, in the case of a realistic simulation of a racing game, each car would have its own characteristics. Not all cars work the same way or are as fast as each other, but they all have their unique characteristics that make them special. Another easy way to test power to weight ratio is to have two people line up side by side on bicycles and have them race in a straight line. The person who can produce a higher power to weight ratio will win the race. The reason why power to weight ratio is so important to understand is that it affects speed, velocity, and acceleration. Even in human physiology, you can increase your fitness levels and improve the amount of power your muscles will produce. However, there is a limit to this gain. And the limit to this gain is the same reason why we cannot produce a vehicle to travel at the speed of light. This is also the reason why me myself as a lineman in football cannot outrun a wide receiver, simply due to power to weight ratio. I may produce more power, but I also have more weight to push. Here is a simple video that showcases power to weight ratio. The basketball has much more weight than the medicine ball. With the same force pushing these two objects at the same time, you can see the basketball stops much sooner. This is because the basketball has more weight, thus needs more power to keep up with the medicine ball.